before we go ahead and take notes, go ahead and pause the video and write down all of these things that you see written on the screen right now. A couple things that we've talked about before that I want to bring into the conversation here are the amplitude and the period of the functions. If you remember early on in this unit, you looked at graphs and you figured out the amplitude and period of the graphs. So the amplitude when you see a function, either sine or cosine like this, where you see a number in front of the sine, that's the coefficient of the sine. That number is what we're going to call, or at least the absolute value of that number is the amplitude. So we'll do some examples as well. And then you've got a number that's the coefficient of the angle, and the angle is theta. That's theta. So theta, that's what you see that. Many times we use Greek letters to represent angle, or just angles or angle measures. And this is what we call theta. Theta, theta. It's a Greek letter. And anyway, the number in front of the theta is always going to be what we call b, but to figure out what the period is, we just take 2 pi and divide it by b. So these are two really, really important things that you need to know. And let's go ahead and just draw the graph of the parent function, because these two are the transformations of the parent functions, y equals the sine of x and y equals the cosine of x. And to get an appreciation for what exactly or why the graph looks like it does, or sine of theta I should say, let's see, I'm looking at my screen here, hold on. Okay, so in order to, like I said, to get an appreciation for why the graphs look like they do, let's go ahead and make an XY chart. First of all, we're going to make we're going to draw a horizontal axis. That's our theta axis, like an x, like y equals sine of x. And then the y-axis, still the vertical axis. And if we make a theta y chart, just like if you ever forget what a graph looks like, all you have to do is plug in values for the independent variable. In this case, the independent variable is the theta, acts just like an x. And we're just going to start with 0. And when you plug in 0 and you take the sine of 0, you're supposed to know that that relates to the unit circle. The sine of 0 is the y-coordinate of that point right there, and that's 0. And then we're going to plot the point 0, 0. And then we're going to go all the way out to 2 pi. So let's do pi over 2, pi, 3 pi over 2, and then 2 pi. So when we just hit the key points here, we're going to plug in pi over 2 for theta. What's the sine of pi over 2? It's good practice also, because you've been learning your unit circle. Sine of pi over 2 is 1. The sine of pi is 0. The sine of 3 pi over 2 is negative 1. And then we're back to where we started at the sine of 2 pi, and that's also 0. So if we label the vertical axis with 1 and negative 1, we can see, and we should know, that the sine can only get as big as 1 or as low as negative 1. And so when x is equal to, or theta is pi over 2, the y-coordinate is 1, or the value of the function is 1. When theta is pi, the value of the function is 0. 3 pi over 2, the value of the function is negative 1. And then we're back here at 2 pi. And so then the question is, well, how do we get from each point to the next? And one might think, oh, we're just going to draw a straight line there, and so forth. But let's put in a couple more values so you can see it's not going to be a straight line. Let's put in pi over 6. So pi over 6, if we divide pi into 6 equal sections, 1, 2, 3, 4, 5, 6, then pi over 6, 1 pi over 6 would be right there. 2 pi over 6 would be right here. That's pi over 3. And then we have 4 pi over 6 and 5 pi over 6. So you're not going to have to do this every time. In fact, you're not going to have to do it more than twice, and maybe not even more than once. But if you plug in pi over 6, we know that the sine of pi over 6 is 1/2. So that goes like that. And so you can see that's not a straight line. It's not on a line from this point to this point. And in fact, what you notice, and maybe you've already seen this before, but a sine curve, it's actually a curve. It's called a sine curve. It comes down like that, kind of like, it comes down here, and it goes up there like that. And what you'd end up seeing is that you would get, the graph would actually repeat itself. Remember, the period of the function is how long it takes to go through one complete cycle. So this actually goes over here to the left, and it goes up, and it keeps going that way, and it keeps going this way. Let's, 3, 1, 2, it should be going like this. It should be going here, and then out like that. And then it goes here, and it keeps going. So it keeps going back and forth forever. And in fact, the domain is all real numbers. But anyway, that's what the graph would look like. That's what the graph of the sine of theta would look like. When you plug in 5 pi over 6, that would be right here. It's also 1/2. And then you plug in 2 pi over 3, that's radical 3 over 2, and so on and so on. So we don't have to do that. The main thing is that I want you to learn how to graph these functions using the 5-point system. And so that's how we graph the sine, and we're going to do the cosine in the next video.